All right. So we are finishing up chapter 6 today. Okay. Which means we will spend the next 2 school days reviewing for our test. So our test is going to be on Tuesday. Okay. So I guess something that I should remind you is that since I gave you back those green graded worksheets, you have a week to get corrections turned in. Okay. I don't know if I ever wrote up when the quiz corrections are due, so I'm just going to say our quiz redos are due tomorrow, okay? And then our 6.2 to 6.3 redos, those worksheets a week from today. So separate sheet of paper, redo any problems that you missed. One thing that I will comment on that a lot of people messed up on, if I have the 5th root of -3, I would need to write that as -3 to the 1/5, where -3 is in parentheses. I had some people specifically on like, I don't know, number 4 maybe, not get those parentheses in there. They make a difference. There is a difference between this and this. Okay, so some of you may have missed a half point for that. Okay. If you have questions about that when we have work time, if there's something specific we need to talk about, we can. But if you didn't like your score, please make the corrections, turn those in. Okay. All right. So today we are going to talk about a geometric sequence. But before we talk about that, let's just talk about a sequence. Okay. So a sequence is a list of numbers that follow a pattern. Okay, I am going to write a sequence down here. And I'm going to write a sequence over here. Okay, so these are both sequences. They are a pattern of numbers. Okay. Can you tell me, as you're writing these down, what's the pattern in that first one that's on the left? What is it, Theo? We're multiplying by 2. What is our pattern for the one on the right? M? We are adding 2. Okay. So here are the 2 types of sequences we need to be able to recognize. The one over here on the left, we call this a geometric sequence, okay? And it's because we have a list of numbers that have a common ratio, is what we say. You guys don't know that. Numbers. Okay, that is a fancy way of saying that we are going to multiply or divide the same number over and over from term to term. So from 2 to 4, I multiplied a 2, and then the next one we multiplied 2, and then the next one we multiplied 2. Why do you think we're talking about this in this chapter? What similarities does multiplying by the same number over and over have to what we just talked about? Savannah? Yeah. When we talked about exponential growth, isn't that what's happening? Right? And repeated multiplication is an exponent. Okay? Now, I do need you also to recognize what we call an arithmetic sequence. Okay? And this is displayed down here. Okay? It's a list of numbers with a common difference. Okay, so when we have an arithmetic sequence, we are going to add or subtract by the same number over and over. Okay, so I'm not going to make you like do a whole lot of like writing the rules or anything, but we need to be able to recognize, are we multiplying by the same number over and over? Or are we adding the same number over and over and over and over? Okay, if we're multiplying by the same number over and over, we have a geometric sequence. If we're adding the same number over and over and over, we have an arithmetic sequence. Okay, so in this list of numbers, I had you write down here, since we are multiplying by 2 from term to term, then our common ratio is 2. Okay. Over here, since we are adding 2 to every term, that is our common difference. Okay. So when I say common ratio or common difference, I'm basically asking you, hey, what number are we using over and over to get to the next one? Okay. Okay. Now, could you write down this one for me? 150, 25, 12.5. And think about what's happening with that pattern of numbers as you write it down. Okay. Not sure what's happening. But there's 2 adults in the room, so I'm going to trust that everything's okay. All right, what's happening? We're dividing by 2. Okay? So we look at that as dividing by 2. What I want you to write is that, okay, we're multiplying by 1/2. So our common ratio, we would say, is 1/2. Because multiplying by 1/2 is like dividing by 2. Yeah? Okay. Now, I'm not going to make you actually write the rules, but you can see, like Savannah said, our link to exponents. If we were to write the equation, it would look something like this, where we have, instead of x, we're using n. That's fine. We're using an exponent, okay? Let's go ahead and go to the next page. We need to be able to determine if we have geometric or arithmetic sequences. So remember, arithmetic means we are either adding or subtracting the same number over and over, where geometric is we are multiplying or dividing the same number over and over. So what I want you to do, I want you and your table to decide 1 through 6. Do we have an arithmetic? Do we have a geometric? Or is it neither one? Okay, see what you can figure out. But you do have to talk to each other. Sorry. With your fingers, show me how many more minutes you need. Okay. All right. Eva, what is number 1? Okay, geometric, which means there's a common ratio, right? What is our common ratio? What are we multiplying by? We're multiplying by -4 every time. Times -4, times -4, times -4. Okay? So if you wrote geometric, go ahead and identify, write down that our common ratio is -4. Okay? All right. Number 2, Rachel, what do you think? Arithmetic. All right, so what is the number that we are adding every time? Okay, so our common difference is +4, +4, +4, +4. All right? Lydia, what do you think about number 3? Neither. Oh, why not? Yeah, we got really excited, right? Because 2 times 2 is 4, and 4 times 2 is 8. But then this would have to be times 4. So that's it. It's neither one. Okay. All right, Connor, what do you feel about number 4?
Also neither.
Also neither. Why not? Okay, we're not multiplying by the same number every time. We're not adding or subtracting the same number every time. Okay? All right, number 5. Aubrey, what do you think? Okay. And if it's geometric, what are we multiplying by every time?
3.
Okay, so we would have a common ratio of 3. 6 times 3, 18 times 3, 54 times 3. Oh, I made you think a little bit on that one, didn't I? Okay. All right, and then number 6, Camden, what do you think? We have an arithmetic sequence. What number are we adding over and over? 8. Okay, so our common difference is 8. Okay. All right, so now I'm telling you, hey, these are geometric sequences. I need the next 3 terms. So what comes after 189 and then? What comes after 72 and then? What comes after -40? Blah, 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 blah. So take some time. See if you can come up with a reasonable way to get the next few terms that come after. So how do you get from one term to the next and then keep going 3 times? Calculators could be helpful here, yeah? Yeah? Hold on. I can go there next door and Miss Lindsay's class.
Oh, okay.
Thank you. Oh, Aubrey. Are you okay?
Yeah.
Okay. What's our common ratio in number 7? Jace.
Times 3.
Times 3, times 3, times 3. So if we keep multiplying by 3, oof, yeah, you need a calculator. Okay, if I'm looking over shoulders, it looks like the next term is 567. And then 1,701. And then 5,103. They all say with enthusiasm. Okay, are we good with that? Okay. Now, I notice that in number 8, they keep getting smaller. So what does that mean is happening? Theo?
Multiplying by 1/2.
Okay, so our brains are probably thinking, oh, we keep dividing by 2, right? Is that what your brain thought? Okay, same thing as multiplying by 1/2. So if we keep multiplying by 1/2 over and over and over, from 72 we would get 36, and then 18, and then 9. Okay. I really like number 9. If every other number is positive, negative, what does that mean about the number we're multiplying by?
It's a negative.
It's a negative. A negative what?
2.
-2. So you should have 80, -160, 320. Okay. Cool. All right, the last thing I want to talk about is this graphing right here. Okay. So when we talk about graphing a sequence, we really are only graphing in the first quadrant. And this is how we would do it. Let's see. 2, 4, 6, 8, 10, 12. Okay, so I'm going to give you some time to do exactly what I did on number 10's graph. Okay. So, the first term is 12. Do you agree? So, our first term is 12. We're just going to make a dot at 112. Our second term is 6. So, our second term is 6. Our third term is 3. Our fourth term is 3/2. Okay. Basically, the x-axis is just saying which number it is, the first, second, third, fourth, fifth, sixth, whatever. And then the y-axis is the actual number. Okay? Do you remember when you did your Skittle thing when I was gone?
Yeah.
Didn't your graph of the Skittles kind of look like that? When you started out with 50 Skittles and then you... Do you remember your Skittles kind of looks like that? Okay. We're not going to connect the dots. We're just going to plot the dots. Okay? All right.